Let's look at this triangle here. What it says now, you have this triangle, a right angle triangle. As you can see, ABC is a triangle. AC is 5, BC is 8 centimeters, C is where the right angle is. You must find the length AB. Well, what you do here, use Pythagoras theorem. Pythagoras theorem says the hypotenuse squared, that would be AB squared. Remember, the hypotenuse is opposite to the right angle. It doesn't come anywhere near the right angle. AC is adjacent to the right angle. You can see it rubs against the right angle. Same with BC. But AB stay far away from the right angle. It's the hypotenuse. AB squared is equal to one of these other side squares. AC squared plus BC squared, the other side square. So, one way I put Pythagoras theorem, it says the hypotenuse square is one of the other side square plus the next side square. So here now, AB squared is equal to 15 squared plus 8 squared, which is what, 225. 225 plus 88, 64. 225 plus 64 is what? 4 and 5, 9, 6 and 2, 8, 289. So AB is equal to the square root of 289, which is what? What's the square root? Let's see now. The square root is square root of 289 equals 17. Nice. So it's 17 cm. So we see here that it is 17 cm. Alright, then we want angle A. Angle A now. So, what we can say, well, should put BAC is the same as A. So, this angle here is what we want. Now, the thing is, A, angle A, the sine, we could use sine, tan, cos. Let's use tan. Tan A is equal to opposite is A divided by hypotenuse 15. So therefore A would be tan inverse of 8 divided by 15, which is what? Let's see. We'll have to put our calculator in advanced mode. So here, with this calculator, I have to say tan inverse, then open bracket, 8 divided by 15 close brackets equals 28.072. Let's say 28 degrees. So we have 28 degrees. So this is 28 degrees. Alright. And then we have angle B. Well, we could use trigonometry to calculate angle B with a sine, cosine, or tan. But we see here that the angles add up to 180 degrees. So, say the 28 at A plus the 90 plus B is equal to 180. So B would be 180 minus 28 minus 9. That's one way of looking at it. So 180 minus 28 is it? Not minus 28. Oh yeah. If when we transpose, what we would have here is 180 minus 28 minus 9. Right? But we could have, just in case this might look a bit confusing, we could have said 28 and 9 is 37. 37 plus B is equal to 180. So B would be 180 minus 37. We could do that as well. Right? So when we do that, we say 180 minus 37. That will give you 143. So B. Oh no. Why did I say 9 here? It's 90. No, my mistake is 90, not 9. I did not put the 0 on the 9 and then forgot that it was supposed to be 90. So what 28 plus 90, 28 plus 90 is what? 90. Then we have 100, 110, 118. It's 118. Right? So B now would be 180 minus 118. So here we have it. 180 minus 118. 180 minus 118 give you what? That's what, 62. Alright, 62 equals 62 degrees. So this up here is 62 degrees. Alright. So that's it for that part. Let's see what's happening down here now. Alright. We have this triangle ABC. We can see B is 110 degrees, AB is 50 meters, BC is 17 meters. Find AC, the length AC. So we're going to find this length here. Alright. So what do we do? We can, first of all, this is not a right angle triangle. And you were not told whether it's a right angle triangle. So this thing about sine equal opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent, those will not work on this triangle. We're going to have to use the sine rule and the cosine rule. You have the sine rule and the cosine rule in your formula sheet, right? So AC now. If we try the sine rule, we say, remember what it says, is that the side A over the sine of angle A is the side B over the sine of angle B. Sine C over divided by sine of angle C. So here now, this side AC over the sine of the angle opposite to it, 110 degrees, is equal to B. Let's use 17 over the sine of angle A. Angle A would be the same as BAC. Even though I wrote A here, I could have it as BAC and B will be the same as ABC. Same thing here. Alright, back to this now. Is equal to 50 divided by the sine of angle ACB. Alright, if we put these two together to form an equation, it wouldn't really help us that much, because we'd have two unknowns. We don't know AC and we don't know BAC. If we put this and this together, it wouldn't help us much either, because we'd have to have AC and angle ACB. What I'm saying, if I put AC over sine 110 is equal to 50 over sine ACB, we would not know AC nor ACB. So this sine rule isn't really helping us right now. We have to go to the cosine rule. I consider the sine rule first because it's easier to deal with. A bit easier. But the cosine rule now. What the cosine rule says is the side A squared equal the next side B squared plus the third side C squared minus 2BC cosine of angle A. Now, applying it to this, what it says is that AC squared equals, another side 50 squared plus the next side 17 squared minus 2 times 50 times 17 times cosine of angle opposite to AC, which is 110. So we can use the cosine rule. Alright? So, here, remember, this is the sine rule and this is the cosine rule. But you have them in your formula sheet, so you don't have to worry too much about dealing with them. Alright? So, what we have is that AC squared is equal to 50 squared. So, with 2,250 it would be. Alright. So 50 squared. Where's the square? Alright, 50. Or what we could do is say 50 raised to the power of 2. 500. And then 17 raised to the power of 289. So it's 500 and 289. So here we have 500 plus 289 minus 2 by 50, which is 100, times 17, which is 1700, times the cosine of 110. So let's work this out as it is. So we have 500 plus 289 equals 2789. So we have 2789 minus 1700 by 110. 1700 by cos 110 times cosine of 110 degrees equal negative 581.43. Negative 581. So it's minus negative 581. You know, it's the same thing as 2789 plus 581, right? So what does that give you? What you have is 2,789 plus 581 equals 3370. Alright, 3370. So that's AC squared. So what we do to find AC now, say since AC squared is 3370, then AC is going to be square root of 3370. So the square root of that now, square root of 3370 equals 58. Alright. Now, I was wondering if the square root sign was on the calculator, but I quickly saw it. If it wasn't there, you'd have to say 3370 raised to the power of half, or 0.5 of 0.5 equal, and you get the 58. So it is 58. So therefore, this length is 58 meters. Alright, we're supposed to find the angles BAC, which is this angle here. So here now, we could use sine rule now, right? So we say 17 over sine A equal 58 over sine 110. So when you transpose and everything, see sine A is going to be equal to, it's going to be 17 times sine 110 divided by 58. Alright? So that's what you're going to have. So let's just jumble everything here and work it out. Just low battery. Just going to let me pause and plug in my charger. Alright, my charger is plugged in. Can continue. So here now, let's just go back to our calculator. And what we have is 17 times, and remember, you have to be careful to make sure your mode is in degree. It's in degree mode, alright? Times the sine of 110, and that will be divided by, let me put this part in brackets. So 17 times sine 110 divided by 58 equals, sine of A is 0.275. So sine A is equal to 0.275. A is what? Sine inverse of 0.275. So A is, back to our calculator, say the sine inverse of this equals 50, let's call it 16 degrees. So this is 16 degrees, alright? Now the thing is, to get the third angle here, we can just say that 110 plus 16 plus angle C is 180. So C is going to be 180 minus 116. So in that case, we have 180 minus 116 gives you 64 degrees. Equals 64 degrees. Alright? Now here, the area. The area of any, well, you can't see that writing very well. Let me change it. The area, what should I erase now? Let's erase up here to make some space. The area of any triangle is half AB sine C. That means you have a triangle, this A, B, C. What you have is half AB, half of this, times the sine, no, I'm saying, what did I write here? Wrong thing I wrote. This AB is supposed to be common A, common B. So what you have, if you have ABC, this triangle, this is small, this side is small c, this side is small a, this side is small b. So it's half a, so it's half of this side times this side times the sine of the angle between them. Alright? So in this case, is half of one side times the next side times the sine of the angle between them. So let's work with this and see what we get when we apply it to this triangle. Here we could say is half this side times this side times the sine of this angle between it. Alright? So let's do that. The area here is half times 50 times 58 times sine 16. So in this case, with our calculator, we have 0.5 times 50 times 58 times sine 16 equals 399. Let's call it 400. So it will be 400 meters squared. Alright? We'll also try it with another two sides. Let's try it with this. The area of a triangle. Let's move this keyboard out of the way. The area of a triangle is supposed to be 0.5 times this side here 17 times this side 58 times the sine of 64. Sine 64 equals, we get a little more than 400, 443, rounding off and so on and so forth. And then if we try it with this, we have 0.5 times 50 times 17 times the sine of 110. Sine 110 equals, alright, so 399. This one is very close, much closer. So there we have it. Anyway, that will be it for this video. So I will see you